Okay, so a note on graphing. We're going to talk about this a little bit. And so when we're graphing a line, there are going to be two things that we're going to be dealing with. One of them will be slope, and the other will be y-intercept. In the case of this particular problem type here, there is no y-intercept, or the value of the y-intercept is 0. And so all the lines are going to pass through what we call the origin, which is the place where the x and the y-axis cross, right there, right there, right there, and right there. And so I'm just going to demonstrate graphing a couple of these things outside of what's in ALEKS to give you an idea of what you can expect here. And so let's say that we had the equation y equals 3x. Well, there is no y-intercept, or the value of the y-intercept is 0, and so we know that that line would pass through 0, 0. The other thing is that that 3 is positive. And the 3 represents the slope, which is how much the graph is going up or down compared to how much the graph is going left or right. And so when we have a positive slope, what's happening is the line is from left to right. As we read the graph from left to right, the line is going up. And so if we have a value like 3x like that, we could see that maybe we have a line that looks like that. Similarly, if we had a line that looked like y equals 1x, we would say that that slope is also positive, but it is not quite as steep. And so it would be a lesser slope, or not quite as steep of a hill if you were trying to climb it, going from left to right. And so again, both of those are positive. And one thing that confuses students often is they say, well, but these points down here are negative. These are in what we call quadrant 3, and those are negative points. And so how can that work? We're not talking about the location of the line when we talk about the slope. We're talking about the behavior of the line. So we're saying as we move from left to right, does the line go up or down? In both of these cases, for the blue line and the green line, they both trend up as we move from left to right, showing that they are both having a positive slope. If we go over to the next graph and we take a look at the alternative to that, something like y equals negative 3x, the line would still pass through the origin at 0, 0 because the value of the y-intercept is 0, or it's not there if you want to think about it that way. But instead of the line going up from left to right, it's going to go down from left to right. And so we would have a line that did something like that. And so again, going down from left to right, you're saying, well, that's negative, but these values, these y values up here are positive. Again, we're not talking about the specific points. We're talking about the behavior of the line as we move from left to right. Again, we go from left to right, that value is, the line is going down because that slope is negative. Again, and if we do the same thing, we look at y equals negative 1x, the line is still going to be going down from left to right, but not quite as steeply. So kind of the inverse, or the opposite of what we observed in the graph to the left. That green line represents y equals negative 1x, and it's going down from left to right, but not as at quite as steep of a rate. The other piece to understand is when we talk about slope, what we're really talking about is a change in y value over a change in x value. And so in math, we like to write things shorthand. We use a triangle to show change in y over change in x. So it's going to be a ratio comparing how much y changes for how much x changes. And so if we look at this first problem here on the left, we see we've got y equals negative 2x. Now, for me to think about that as slope, I need to think about it as a fraction of change in y over change in x. So I'm going to rewrite that as a fraction, y equals negative 2 over 1x. What that tells me is that I'm going to go down 2 for every 1 that I go to the right. So if we come take a look at this graph over here, we get our pencil, we start here at the origin. We know that the y-intercept is 0, or there is not one showing here. There's no plus or minus anything. So down 2 and to the right 1, down 2 to the right 1. And I could put a series of points down 2 to the right 1. I could continue for as long as I wanted to. I'm going to choose to stop there, but you could keep going. And then what we need to do is go ahead and put a line on here, and you can use any pair of points to put the line on. It will snap to those points, and you can see that this line follows this pattern. Again, the slope is negative because it's going down as we move to the right. And this slope right here, -2, tells us that we are going down 2 for every 1 that we go to the right. We'll try another. -4x. So y equals -4x. If I write that as a ratio or a fraction, y equals -4/1x. That's going to tell me that that's telling me that I'm going to go down 4 for every 1 that I go to the right. So starting at the origin, down 4, 1 to the right. We can do I'll put a point there at the origin. We can do 1 more, down 4 more, to the right 1 more. And those points will all land on this line that we've created here. So y equals 3x. As a fraction, we see y equals 3/1x. So starting at the origin again, this time we're going to go up 3 because it's a positive slope. So up 3 to the right 1. From that point, up 3 to the right 1. Okay, and we'll do 1 more. Y equals 2/3 x. I'll do a few more since I didn't notice that there was going to be fractions in here. So this tells us the change in y is 2, the change in x is 3. So this is positive, so it says to go up 2 and to the right 3. So again, beginning at the origin, up 2 to the right 3. Up 2 to the right 3. Okay, we'll see if we can get another fraction. When we did, y is equal to 1/4 x. And so the change in y is 1. The change in x is 4. This is positive, so we are going to go up 1 to the right 4. And from there, up 1 to the right 4. We'll see if we can get one more with a fraction in it that's negative, maybe. We're not getting a negative one, so I'm going to pretend that this is negative. If I had a negative out here in front, it would tell me to go down. This is positive. I'm changing the problem to make this negative just for an example. So if I had -4/3x, it would tell me to go down 4 to the right 3. Down 4 to the right 3. And then our line would look like this. And again, if I click to check here, it would say it's incorrect because this is positive, so it should be going up this way. I changed it just for an example to show what a negative would look like.